Well, good morning, good afternoon, and good evening, everybody. My name is Simon Bate. I'll be your presenter for this Scriptorium webcast on localization and the DITA Open Toolkit. First, we'll just start a little bit about me. I'm a senior technical consultant at Scriptorium. I've been here at Scriptorium for a little bit more than 4 years. I've had about 30 years, I like to say I've had 30 years experience in technical communications. 10 years as just writer, 10 years as a manager. In the past 10 years I've been doing what I really love, and that's tools development. Now you can't do tools development without telling people how to use the tools, so I've also added to my resume training. So I do a lot of the training here for Scriptorium. I've had, with Scriptorium, I've had about 4 years of working in the DITA and DITA Open Toolkit. And so I'm going to be sharing with you a little bit of my experience working, trying to localize transformations with the DITA Open Toolkit. Just a bit about Scriptorium. We like to focus on content strategy for technical communication. We work with all sorts of companies, government agencies, and so on in their content strategy. A typical customer will come to us with a problem. They've been told they have to go to XML, or they have to localize to 10 languages all of a sudden, or they've got old and outmoded tools, and they'd like to move into the 21st century. We'll analyze your situation, propose a solution. We can implement that solution, actually help you transform your data to that solution if necessary, and we can provide training. An overview of what we're going to be doing today. So first we'll talk about the XML-lang attribute, the cornerstone on which most of the localization in the DITA Open Toolkit is based. We'll look at the DITA Open Toolkit, how it deals with strings. We'll also look at how it sorts indexes. And then we'll talk about two special cases. One is the PDF plugin, and that's a lot because there's a lot of things that are really done right in the PDF plugin, but it does behave somewhat differently from the standard Open Toolkit plugins, and so we'll look at some of those differences. And then we'll also talk about the HTML help plugin, which has problems of its own, mostly going back to the fact that it was created long before Unicode was really well used. So how we're going to do things in localization in the DITA Open Toolkit. We base things on an XML attribute named XML:lang, and use this attribute to specify the language and locale that a particular piece of content is encoded in. Now, usually you apply the XML:lang attribute to topics. This is usually at the root. So in your topic element, you'll say XML:lang, ENUS, or FRCA, whatever your language is. You might put in the topic or concept. But you can apply XML:lang to any element. And so if you do have text with mixed languages, there are times when it's useful to put XML:lang on a particular element. Let's see. Now you can also apply XML:lang to maps and bookmaps. And again, you want to apply it at the root of your map or the root of your bookmap. Now, one misconception that some content creators have is if you're dealing with a map, you can set the XML:lang attribute in the root of your map and be done with it. Well, unfortunately, that's not the case. When you send your content out for localization, either you or your localizer is going to have to set in each of your topics in the root an XML:lang attribute. And this gets back mostly to the way that, at least for HTML, that the DITA Open Toolkit processes your topics. It does deal with the map and pulls together tables of contents and things like that from the map, but when it actually transforms your topics into HTML files, it deals with them one at a time. And that's not in the context of the map, it's just that file. And so as you're processing the file, the Open Toolkit will look at your topic and look for an XML lang attribute and use the attribute that is specified there, or use the value that's specified there. Now, if you don't specify XML lang, it does default to ENUS, that is English in the US form. You can override this default. There's a parameter for running the Open Toolkit called default lang. And if you specify default lang to be another language and localization pair, then that will be used as the default for processing all of the files in that run of the Open Toolkit. Now, as I said in the intro, we'll talk about strings and index or sorting. Actually, no, I didn't talk about that, did I? So the two main points of localization are, two focal points of localization are the strings that are in the files and then the sorting sequence. And we'll talk a little bit about the strings now. So typically when you have text processed by the Open Toolkit, there are some pieces of information that aren't in your content, but they do need to be inserted when you're processing topics. So for instance, if you have something that's chapter or appendix based, you're going to want the word chapter added at the top of the chapter or appendix. This does not come from your content. This actually comes from the Open Toolkit. In a similar fashion, for all your admonitions, such as note, caution, warning, you don't need to specify the actual word, note, caution, warning in your content, but that information comes from the Open Toolkit. Also, your output may have footers. You may have a confidential statement. You may need to have some statement of proprietorship. There's all sorts of things you may want. Again, that's not in your content. You want that to come in from the Open Toolkit. And the way the Open Toolkit does this is with a template called getString. And in the XSL that processes your DITA topics into output, the XSL calls getString and passes in the name of the string, and then it returns the actual string in the current language. And how's the current language determined? It depends on the XML lang attribute that's set in your topic. So the Open Toolkit is nicely organized. All of these strings are maintained in a common location. We'll take a look at those in just a minute. And the Open Toolkit supports 50 languages and locales. So a little bit more about the template itself. So I'm just doing some stuff on my other screen here. So the getString template itself, here we have a version of the Open Toolkit, DITA OT 152, and in the XSL common folder, you'll see this template or a style sheet called DITA Utilities. And DITA Utilities is where the getString is defined. So as I said, when you call getString, you pass the string name and it inserts a single string. And of course, it uses the XML lang to determine which language the string is. Now, when you call getString in the XSL, it looks at the nearest ancestor to your current element, to the current context. So if that's at the topic level, it uses whatever is defined as XML lang up at your root. And then actually we talk about the strings in the next slide. So how does getString work? Well, if this is important, if you're going to modify your DITA Open Toolkit, if you're going to create a plugin and you need to add strings to your plugin, it's a good idea to understand then how does getString find its way to those strings. So this all begins with, again, the XSL common folder, and there's a file called allstrings.xml. Now, allstrings.xml is actually created by the integrator. If your plugin specifies that you have a strings file you need to add, it modifies the allstrings template and generates your allstrings file. And let's just take a look just for a minute at the all strings file. So in this case, the base level all strings file just contains a single entry for string file strings.xml. Now, because I've run the integrator, I'm also pointing to a strings file of my own that's being added to all strings. But the important thing to do is to focus on this strings.xml file. So all strings points to strings.xml, and then in strings.xml, which is also in the common folder, we list all of the localizations that are supported by this, well, in this case, by the DITA Open Toolkit. So if we open this now, if we open strings.xml, we can see that there's a list, and here we go. For each XML lang attribute that we might find in our document, we want to point to a file that actually contains the strings for that language in locale. So in this case, we're looking for Arabic, and the file is the strings AREG, or Egypt, or Arabic Egypt also matches this AREG. We've got Belarus. We can scroll all through here. We can see we've got English, Greek. You can see all of the locales that are actually built into the DITA Open Toolkit. It's rather an impressive number of files, actually. So then each of these files themselves then contains the strings. And let's take a look at how those strings are organized in these files. So let's see. For want of a better one, let's just go down and use the ENUS so we can understand. Actually, no, let's not do that. Let's do German, because what I want to do is show you the contrast between the name and the actual string that gets put in place. And I'm going to scroll down here a little bit down to where our admonitions are defined. So here we have a string, and the name is note, and here's the German text, Anmerkung, which is inserted in place of when we have a German note. If we have a tip, we want to insert the German text tip, fast path, and so on. So you can see each of these strings, we call getString passing in attention, and what the getString template outputs in our output file is Achtung. So that's the basic idea of how getStrings works. So we go from all strings to our strings.xml. Strings.xml for each language then points to a specific string file, and then the string file actually contains the actual strings. Now we can add this to our plugin, and from a plugin we can either add new strings to the strings that are used by the DITA Open Toolkit, or we can override the existing strings that are defined in the Open Toolkit, because the way that the strings architecture works, anything that you define, anything that you add to the strings architecture is used rather than the things that are defined at the base level in the DITA Open Toolkit. Now, when I implement strings in my plugins, I always like to parallel the DITA Open Toolkit architecture. So let's just bring that back on screen. So here we have DITA Open Toolkit. We've got XSL and Common. And let's scroll up here and look at our plugin. So here we have a plugin, our SPS Help plugin. And in here we have then an XSL folder. And within XSL we have a Common folder. And so just as we had strings in Common in the DITA Open Toolkit, here we have SPS strings.xml in the Common. But let's back up just a bit before we get to that. So the first thing we do is, well, actually, no, let's talk about strings. So if we remember, the strings.xml file in the DITA Open Toolkit points to all of the strings that are all the strings files, the language files that are defined for all the languages. And we can do the same thing here in our plugin. Now in our plugin, we're actually only covering a few languages. So what I've done is I essentially copied the strings file, and then I commented out everything else except for the languages that we're supporting. And you can see it's not entirely empty. So we support English here, and we've added Japanese, Chinese, and Russian. And if we need to, later on, we can come back to this file and just uncomment new strings. And then to match those languages, I've also created strings ENUS, strings Japan, Japanese, Russian, and Chinese. And so in each of these, I've actually defined the strings that I'm going to be using in that language. So you can see here, I've got my own strings defined along with the text that we need to appear in this localized language. So here we have related concepts and the Japanese string we want to use. Now, the final thing we need to do when modifying our plugin, of course, is we need to tell the plugin to add our strings file to the all strings, and we do that through the plugin, plugin.xml file. So let's go there. Here's SPS help, and I'm just going to bring this on screen. So here's our plugins.xml file, and you can see here we have a feature extension DITA XSL strings, and here's where we identify the SPS strings file that we're going to use to identify where all of our various language strings files are. So then the integrator comes along, sees this in my plugin.xml file, and then modifies all strings. So that's where we've got SPS strings here. Here's all strings. Whoops, shoot, double clicked. Where did it go? I'm just going to have to bring that back. Sorry about this. Oh, there it goes. Okay. So here we have our, sorry. Oh, okay, we'll use a different editor. So here we have our all strings file, and here's the strings.xml, and then here's the string file that was added via my plugin. So now we have SPS strings.xml. And so now we're all plugged in and ready to go when we run our plugin. Now, inserting strings this way is useful, it's okay, but is not complete. It's not the full way that we want to deal with things, because all that this getString deals with is a single word or a single string. And this doesn't meet the needs of all our languages. So, for instance, there are sometimes we need to insert a string, and the string and the value may be in a different order. So, for instance, when we write a figure in English, we're perfectly happy going to getString and saying insert the word for figure, and then our XSL calculates what the actual figure number is and inserts that number in our output. If we're dealing, though, in Hungarian, what we have to do is first determine the number, and then we have to output our string. And in Hungarian, it turns out to be abra. So here's our Hungarian figure. And that's, if we do something this way, of course, our XSL has to be customized for language. So now we've introduced a choose statement. We've got to say, is XML lang ENUS, or is it HU, which should be for Hungarian. Similarly, sometimes we want to do multiple string substitutions. We don't just want to insert one string. We need to insert two strings around some content that may be extracted from our current context. So, for instance, when we do Japanese chapter numbering, a Japanese chapter number actually has 3 parts rather than 2 parts in English. The first is the kanji dai, which is an ordinal. So this is like saying the second, and then the actual number, and then the kanji shu, which says chapter. So again, if we do this through getString, what we're going to have to do is add some specialized code to our XSL that says what is XML lang, is it JAJP? Oh, okay, in that case we have to do things this way. So again, it's not a good idea to have to clutter up your XSL transforms with all of this locale-specific language. It would be a whole lot better if this was done somewhere else. Another example, European dates. If we're in Europe, we want to represent today's date. We'll, using an entirely numerical form, what we'll say is 14/9/2011, versus here in the U.S. where we say 9/14/2011. So now, this is a limitation imposed by, or just by the way that getString works, and we'll see in the PDF plugin they have a much better solution for this. Now, in addition to string substitution XSL, there are other places where we actually need to substitute things when we're generating output through the DITA Open Toolkit. Some areas I've run into is I've got some static HTML pages that may need specific words that are language specific. I'm thinking in particular we have a Tripane help or web help system, and there are words that need to appear on those on the HTML pages. Also, there's JavaScript that works behind the scenes in this help, and the JavaScript sometimes has to change the string that's available in the help. So for instance, the help supports browse sequences, and there are arrows you can click on. There are tooltips on those arrows. When you reach the end of your content, our web help says there are no more, you reached the end, you cannot click any further. And of course that has to be put in dynamically, and so we need to go and touch the JavaScript and put in language specific information. Now, the way that I've approached this is I go and I need to modify these files. The files that are going to be localized, what I do is I go in and actually add, I replace the text. So if we have an HTML or a JavaScript file where there's a piece of text that the user will see, I replace that text with an ant property. And I'm trying to think if I've got an example that I can bring up right now to show you. Yes, I do. Hang on. So here's some JavaScript files that we have. These drive our web help. And I can search for $Reese. And so here we have an example. So here we have a title on a node, and this actually says click to collapse. And instead, what I do is I'm using a string, the collapse string, and what I want to do is have ant substitute that. So the place I find the strings is then I've created an I've created an XSL transformation that goes through the same properties files that we were looking at that are used by getString, and instead what I do is I parse those files and I create a series of ant properties based on those strings. So then these properties then appear, for instance, here. Let's take a look here. We were looking at a collapse string, so we can see here is our property named collapse string. And we can find it here. So here we now have this entry with the key collapse string, and this here's the Japanese that's replaced in that place. Now, how those strings actually get substituted is we read this file in, the locale list, and tell Ant to turn this file into a series of properties. This is actually through an Ant customization that's part of the DITA Open Toolkit. And I end up with a whole series of Ant properties. And then I can use the Ant copy element with a filter chain, and in the filter chain I can say expand properties. And what expand properties does is each of these places where there's a property, an actual Ant property referenced, it'll actually go in and insert the string in place. So in my output now, I have JavaScript that in place of these properties now has Japanese or English or whatever I need. Let's go back here just for a minute, make sure I've got everything. Okay. So that's string substitution, both in XSL and in non-XSL files. Now, another thing we need to deal with, of course, is sorting indexes. And, of course, we know the sort order is language dependent. In English, it's fine. We can just say, okay, let's just take the English alphabet. We can sort things. But say we're dealing in French, and we've got a whole number of diacritical characters. We need to sort our index, or we need to sort our glossary, not just by those, not just by the English series of characters, but by the characters along with their diacriticals. There's also, you know, in other languages, Japanese, Chinese, the sorting is done entirely differently. So the Open Toolkit actually provides, through the dost.jar, DITA Open Source Toolkit.jar, there are routines that that provide our index generation. Now these routines are actually only used by the Java help, Eclipse help, and HTML help transformation types. So if you want to look at sorting indexes, you can go to one of those transformations in the DITA Open Toolkit and you know, look at the Ant project file, and you can see how it's called through pipeline. Now, if you're adding your own transformation, you're going to have to figure out how to sort your indexes. And there are three real alternatives you can use. The first is, if you want, this is sort of the far out version, you can find the sources for dost.jar. You could potentially go in and modify those sources, use the Java compiler, build your own dost.jar, and then add that to your plugin. Now, another way you could do it is roll with the punches, as it were. So you use the output from dost.jar and then run that output through a transform of your own. And that way you can get your index or get your glossary looking the way that you want. Actually, this is mostly talking about index generation rather than glossary. And finally, the third alternative you have for doing indexes is, of course, you could write some routine, whether it be XSL or in some other language as part of your plugin to generate your own index, provide your own sorting. Now, of course, the thing is that if you do something like that, you've got to make sure that all of your intended localizations, there is going to be a way for their sort sequences to be used. One of the advantages of the Open Toolkit using dost.jar or using Java for doing this sorting is that Java itself comes with a whole series of sorting sequences. As long as the language that you're going to uses a Java sort sequence, you know that at least you're going to have your index sorting is going to be done correctly. Okay, let's move on and talk about the PDF plugin. So, as I said in the introductory words, the PDF plugin does things somewhat differently than the mainline DITA Open Toolkit. And the first of is it uses its own string substitution. Also, it doesn't use the XSL common templates, so all the files, all those things that I showed you in XSL common, all those language strings files, those are essentially thrown out the window by the PDF plugin. They define their own. Now, instead of the plugin architecture, the PDF plugin has a customization folder. So if you want to make changes to the PDF plugin, you make your changes in customization, or you essentially add them to the PDF plugin. And also, the PDF plugin has its own index sorting mechanism. So we'll take a look at that in just a few minutes. So in the PDF plugin, string substitution, instead of using getString, uses a template called insert variable. And this, in the PDF plugin, is in the file demo fo xsl common. And I'm just actually off screen navigating there. So here we have our FO. We're in demo FO. And we go to, and let's demo FO XSL common, and here's where vars.xsl lives. So this is where the template is defined. Now the strings files that are used by insert variable live in demo FO config common vars, and we can see here. This list, of course, is much shorter than the 50 languages defined in the mainline DITA Open Toolkit. The FO plugin defines right now 7 languages. So we've got German, English, Spanish, French, Italian, Japanese, and Chinese. We'll take a look at the contents of those files in just a minute. So the insert variable template, it can do simple string insertion. We can just use it and add just a single string. And actually, why don't I just do this right now? I'm going to open it up. And of course, I've got to bring it on screen. So here we have our variables. I'm looking at the Spanish file, ES, Espanol. And actually, doesn't look like many of these are translated, does it? Oh well. Tell you what, rather than do that, let's just use the English one. That way there's no confusion. So here we have, here we've defined a defined a variable, and its ID is product name, and it has the value open topic. So this is just like getString. It just is going to insert a single string open tick. We can see other forms of this. So we've got table of contents is just contents, index continued string is continued, and so on and so forth. Now, the place where insert variable is different, though, is that it allows complex string insertion. And so the strings that are defined in this file can contain placeholders. And what you do is, well, let's look at the placeholder. So here we have a string. We have variable ID is body odd header. So we're defining what the odd header is going to look like in our document, in our PDF. And we have a parameter, the product name, and then we have a non-breaking space, bar non-breaking space, and then another parameter called the heading, another separator, and then another parameter that contains the page number. So when we call insert variable, we pass it 3 parameters, and the parameters are passed by name. So we'll pass it a prod name parameter, a heading parameter, and a page num parameter. And then insert variable then knows where in this string to insert those parameters. And so this solves 2 problems. One, we can have text and variable information mixed up in a single string, and because these are, the parameters are named rather than the old C print string, or sorry, printf, where the variable, the parameters were numbered. In this case, they're named, and so the order is entirely up to the content of this variable definition here. So if we're going to do something for a date, then we can have a parameter for the month, a parameter for the day, a parameter for the year, and it's just a question of in which order do those appear. Now, if we want to add our own definitions to this to the insert string architecture, as I mentioned, there's a customization folder, and so we can find customization common vars, and in here, if we needed to add some strings of our own, we could just simply create a file here named just the same way as the files are named for the just the same way that these files are named. So for English, we'd say en_us. We would name it the same and insert it here, and there we could define our own variables that we were going to use with the PDF plugin. Generating indexes in PDF. So one thing you have to understand about generating a PDF file is in the processing of the transform, at one point it takes all of your topics and merges them together into one large XML file. And at the same time all of those topics are merged into a single file, the merge process looks for all index entry or index term elements in your document, gathers them together, sorts them using Java, and then adds them to your merged file. And so we can see this, and that merged file is called stage 1. It'll appear in your temporary folder. As long as you've said don't delete the temporary stuff, you can see this. So here we have stage 1, and we have all our topics merged together. You can see by the slider how big the file is. And if we come way down to the bottom of the file, we find here we have open topic index. Let's scroll up a little bit so we can actually see the beginning of this. There. So we have open topic index, index groups. And so each of these, each is assigned to a group. So we have group, and here's group A, and so we've got ant as our entry. So all of this stuff is done for you in the PDF plugin. The interesting thing is, though, then you have, if you need to do anything in your PDF to actually generate an index of your own, you then have to do formatting. You have to format this yourself. Now, so just to point out, all of these index elements, when they were sorted, it uses throughout, it uses this open topic index namespace. Now, the index entries that are here actually also appear in place in the text. So if you search the file, you'll see where that index term was originally referenced. Now, another thing that's provided by the PDF plugin is handling special characters and fonts. Now, the reason this occurs is when we start going to other languages and other fonts, there may be characters that there may be special characters in particular languages, and those characters are not represented in typical fonts that we use. And so there's a mechanism in the DITA Open Toolkit, and this is part of the processing of this merged file. The DITA Open Toolkit goes through all of your content and searches for these specific characters. When it encounters them, it adds FO instructions, that is XSL formatting option, or XSLFO, to use a slightly different font, to use a font essentially where we know that character is defined. So we do this in two parts. The Open Toolkit does this in two parts, or the plugin does this in two parts. First, we assign a series of characters to sets. And so if we look in config FO I18N, we can see here, again, we have a bunch of files that are named in the same way as they were in the vars folder. These contain slightly different things. So let's open one of these. So in this file, what we do is we create these sets and assign particular characters. So this is saying if we have the copyright, if we encounter the copyright symbol, if we encounter a trademark symbol or a service mark symbol, we want to make sure that's assigned to the font symbol superscript. So that way we don't worry if the actual font used for a body copy doesn't support these symbols. We know that actually they're going to be formatted using a font that does support them. So we've got the characters and we've assigned them to sets, but where are these font sets defined? Well, the sets are defined in config FO up higher, a little bit higher, in font mappings. And we're going to open that. Essentially what font mapping says is we have these names, so let's look for symbol superscript. And so here we have the font symbol superscript, and we want to make sure that we use Helvetica for that font. So that's where these names, these sets, are actually assigned actual fonts. And if you notice, this is what happens when we encounter this in a sans serif font. If we encounter it in a serif font, we can assign it to a different font. So here now we're using Times, and so on. If we needed to do something in monospace, and we had this, then we're going to be using the Courier face. And again, you can add your own customizations for this. This talk, by the way, is based on a white paper that I created, and you can find it on the Scriptorium publishing site, all on the same topic. And at the time when I wrote the paper, this topic, I shouldn't say swept under the rug, but what I said, there's not a lot of documentation on it, but there's a point or two, a place where is documented better. Since writing the paper, we've actually encountered a use where we needed to use this, and the files that I showed you are essentially all you have to do for doing things. The circumstance we encountered in this is in using the PDF plugin. If you're using the free Apache FOP processor, it only supports a small handful of fonts. So we had to ensure that when we're using a particular character, an M dash, that M dash was actually available in the font. So I was able to go into the this enus file, add the M dash character, and assign it to a new character set. And then I was able to define a new character set and said, when we use this, let's use a font that we know does support the actual Unicode M dash character. Sorry, it wasn't an M dash, it was a non-breaking hyphen, which is much more obscure and much harder to find. All right. Moving on a bit now from an implementation that is good to an implementation that needs a lot of help, essentially, to be frank. Again, as I said in the introductory words, HTML help was invented more or less before Unicode was really popular. And so it's based in Microsoft encodings or Microsoft font encodings, and does not use Unicode, and has been updated to use Unicode, which I think is a real shame. Two of the really big things on the Unicode support is that if your content contains Unicode, the HTML help compiler will not generate an index, and it will not generate a search index. Now, you may occasionally There are some languages that actually you do need to create them in Unicode and then run them through the HTML help compiler, and it will take them. This is Japanese and a few other Asian languages. But what's happening there is it's not really processing the Unicode. What it's doing is behind the scenes it's taking that Unicode and then converting it to multi-byte characters in those languages. Another thing, the HTML help compiler requires you to specify the encodings, and these are going to be language dependent. They vary based on what language you're in. We'll talk about this in a little bit. And you also need to choose your fonts carefully because, of course, the HTML help displays things using a limited set of fonts. And so, if you're working in a language that doesn't have much character support in those fonts, you've got to figure out other ways to support those. And this goes particularly to the index and table of contents. Now, another thing with running the Microsoft HTML help compiler is when you run the compiler, it really has to be run on a language-specific machine. So the machine has to be configured for that target language and booted using configuration. So this adds a real added complexity to trying to build HTML help reliably through the DITA Open Toolkit. Now, after I wrote my paper, I'm sorry I've forgotten the name right now, but if you go to the again, go to the Scriptorium site, somebody contributed a comment talking about a program from Microsoft called apploc.exe. I haven't had a chance to try this, but apploc will supposedly reconfigure a machine on the fly so that it's as if it were working in that target language. Now, I have seen some mixed things on experience with apploc, but if you need to do this, if this needs to be part of your processing, then please go to first go to the Scriptorium site and then follow the links there in the comments on my paper. So I'll talk just briefly about file encodings because this is important for dealing with these Microsoft HTML help files. So probably all familiar with Western font encoding. We're talking here about text files, things like a Perl script or a document you might open in Notepad or something. A number of years ago, the dawn of time, or at least dawn of computing, had text forms. ASCII was a popular one. IBM had a form of text encoding called EBCDIC. These were both limited forms. They were bits and could barely squeeze in 2 versions of the alphabet, the numbers, plus a few special characters. Eventually, they added an 8th bit, and so that added it to 255 possible characters. But in doing so, of course, well, sorry, let me back up a bit. Within those 255 characters, then, as people started saying, well, we need to support our language too, not just English. So the characters of diacriticals, various other characters were added to the character sets, but it wasn't in an organized fashion. So there were a variety of different representations for those various characters. The ASCII format then morphed into the ISO 8859, and this format, there are a number of variations on it, and each one is dependent on which language you are in. This is the realm in which the HTML help compiler works. Now, in addition to that, in Windows, there are what we call code pages, and this is yet another way of displaying information on screen in Windows. And all of this was supplemented or supplanted by the Unicode standard, where Unicode contains the glyphs, code points for all 300,000 known characters in most common writing forms. Now, in non-Western writing, there were other character-based formats that arose. In China, there's Big 5. In Japan, we have the Shift-JIS format. These are multi-byte encodings, and they're still around. They're still used, but in these countries too, they're moving much more to Unicode format. So Unicode really is the best way of representing all this information, but it's not available for the most part, to the HTML help compiler. So one of the reasons I'm bringing all this up is that when we open a text file, in most operating systems, programs have no way of knowing when they open a text file what the encoding of that text file is. There's a couple of ways we can identify the encoding of the file. So for instance, if I were to open a big 5 file, it's certainly a character-based encoded file. But if I opened that in Notepad, Notepad would just say, oh, I don't know, I think I'm looking at ASCII, and it would try and display it to me as an ASCII file. This isn't going to work, particularly if we're trying to do things like open files in the HTML help compiler. So there are ways we can identify the encoding. And in the first place, the file can contain information about its encoding. So in HTML, we'll see a meta tag that contains content, character set, Windows 1254. This is one of the Windows code pages I'm talking about. Also in XML, we have, in the XML declaration, we have an encoding attribute, and the encoding attribute says this is a UTF-8 file. There are other ways of identifying information. This all dependent on file type. Now Unicode also uses, so UTF-8 of course is a flavor of Unicode. Unicode uses another another way of identifying files, and that is a byte order mark. In a Unicode file, this occurs in the first byte or the first 2 bytes of the file. And it's used for 2 reasons. So the first reason is just to identify something automatically as a Unicode file. But also in other Unicode architectures such as UTF-16, UTF-32, it's also used for determining the order that the bytes appear in. Now, the other way that we can determine a file encoding is just by actually scanning through the contents and looking for particular marker characters, characters that it would identify to a particular program what encoding is. That's not usually things we're talking about, but I wanted to add that as another way. So the HTML project files, HTML help project files, each has their own peculiarities, and this all has to do with the encoding. So in the HHP file, which is the help project file, the driver file essentially for HTML help, we have a Microsoft language ID. So this guides the HTML help compiler in which language we're working with. This, as opposed to some of the other things we've looked at for encoding languages, uses an entirely different scheme that's invented by Microsoft and uses a series of values that they have assigned to each language. In our HHC, that is the table of contents file, it's more or less an HTML file. But we found this file cannot include the byte order mark, the BOM, at the beginning. If it includes a BOM, then the HTML help compiler bombs out. It stops working. So one of the things we have to do is make sure we remove the BOM when our HHC file is created. Also, the table of contents, as you see, uses a meta to indicate the encoding. And when we actually display this table of contents in our final CHUM file, if we're using non-Western language, we may need to specify a font that supports those characters. The index is a similar way in terms of fonts. That's what's really peculiar about that. And finally, our HTML content, the actual content that's being displayed by the HTML in HTML help, we also use a meta tag to indicate the encoding of those files. Now, we found that when working with languages and localizations and trying to make the DITA Open Toolkit work for HTML help, we have to track everything. I just wanted to share with you for a moment one of the ways that we track these language encodings. So one of the things I've had to do is actually create a spreadsheet. And so I can say for each of the localizations, I want to identify the ISO code that's used for that language, and then the HTML encoding, the encoding used by the HTML workshop, the table of contents, the Microsoft language specifier, and then some additional information. Here's the font. For instance, in Japanese, we know we needed to use MSP Gothic as the font when we generated our table of contents. So I'd really advise, if you're going to be doing something like this, it's a good idea to organize your information for all of your localizations in a spreadsheet. Just keep track of that. I was then able to later, oh joy, there we go. I was able to use a spreadsheet later and assign some properties again in the strings file that we saw at first. I could in that strings file I was able to create my own strings for each of the encodings for each language, and that way I've got this encoding available to me when I need to do my transforms. So we have to modify the file encoding so it can be used. Those files can be used by the Microsoft HTML Help compiler. Now, one way we could do that, when we use XSL to generate files, we can specify the file encoding. But my experience has been that the files get, when files get moved, when they get touched in other ways by ANT, sometimes something will come in and say, oh, you don't want that encoding, this encoding, typically Unicode. And so the encoding gets reassigned. So to save headache, what I chose to do is all of my initial output is Unicode. So everything that I do when I generate a file through through Excel, I use Unicode as the output, and then later I go to the files and I use various ways to change the encoding. Either, well, I need to change the encoding or to remove the BOM. So, and we're getting really close. We're getting close to the end, but we're also getting close to the end of the hour. I think I should make it. So to change our file encodings, what I did was I used the ANT replace statement. And so in this replace statement, I can look for the string charset UTF-8. So here's one of the benefits of saying everything's going to be UTF-8, because that way this string, I always know it's going to be in this form. And then the char set, the actual replacement is character set, and here we have another ANT property, HTML encoding type. And so again, these properties are available. The values of this are available to ANT, and so ANT then replaces this with whatever is the appropriate encoding type for this, for my current language. Removing the BOM, I can also do ANT, and when we do this, actually, it turns out we need two copy operations. And the first, what we do is we take our file that we want to remove the BOM from, and we copy it to a temporary location. Then we copy the file back. And when we copy the file back, we specify an encoding. And if this encoding is not Unicode, then ANT in this copy operation actually removes the BOM for us. So that was a nice side effect. I was very glad to discover that was there. And I'm just looking for a file so I can show you both of these operations. So here we have our replace operation in ANT. So we can say here we're replacing our character set. So essentially in all HTML files, what we want to do is search for the string content text HTML char set UTF-8 and then replace it with content text HTML char set HTML encoding type. And then to remove the BOM, here we copy our files to a temporary location, or we copy particularly our HHC, the contents file, because that's what causes the problems. And then when we copy it back, we say we know that the encoding currently is UTF-8. Then we copy it back to the our target location, and now we specify our TOC encoding type. So if this is ISO 8859, then we know that the BOM is going to be stripped out of our files. And we've talked already about specifying the fonts for the TOC and the index. Essentially, and you can see more about this in the white paper, there's an HTML tag object, and this needs to be the first tag within the body, And within the object, we add a parameter, name, font, and then for the value, we specify the font that is to be used for that, for the table of contents or for the index. So, all in all, the DITA Open Toolkit has some good basic support for localization. The strings maintained in common location, they're fairly easy to add to, fairly easy to maintain. Although the indexing support could be a bit broader in the DITA Open Toolkit. The PDF plugin offers great approach to strings in the insert variable. The HTML help can be localized. I've been quite successful at doing that. It just takes a little bit more work